And the key is the rolling program of mission-specific platforms, or MSPs, because the Arctic was only the beginning. So a year after the ice, a complete contrast in Tahiti.
I couldn't believe it within the first days that I was offshore just doing the project. It was just a dream.
In Tahiti, the aim wasn't to go back millions of years, but to our more immediate past. Locked in the fossilized coral below the seabed, a time-lapse recording of sea level changes towards the end of the last ice age, some 10 to 20,000 years ago.
Corals, they grow like trees. They have annual growing rings. If the sea level is down, the corals will die. And as soon as the sea level is rising again, the corals start growing again. So we have different sequences of corals and non-coral.
Vital data to help predict sea level changes in our near future. But retrieving it posed brand new challenges.
Tahiti was very different from the Arctic. For a start, it was a lot warmer.
Heat was one of the problems or challenges.
Noisy, it's smelly.
Rain, heavy tropical rain.
We were working 24 hours a day for 6 weeks, a mile from the shore, and we never once came into port.
But nothing got in the way of making the expedition a success.
We got more than 600 meters of corals with a very impressive recovery of coral reef records.
And all the time, they were working in one of the most fragile environments on Earth.
We wanted to avoid any impact on this very sensitive coral reef ecosystem. That's why we always use a camera.
We load a downhole camera down the drill string and observe the seafloor.
Just to make sure that we didn't impact at all.
If there wasn't a live coral, we would then lower the drill string to the seabed and start coring.
A system ECORD refined on the Great Barrier Reef, the companion MSP to Tahiti, in 2010. A remote submarine camera explored the reef looking for safe seabed and then helped direct the drilling, sending back some fascinating images in the process. The Great Barrier Reef expedition had the same aims and the same results as Tahiti, bringing to the surface cores filled with ancient corals, some still as spectacular as when they were alive thousands of years ago. Together, these two MSPs represent a powerful data set.
The results from Tahiti and the results from Great Barrier Reef should complement each other, and we should be able to get a very good record of sea level rise.
It's not finished yet, because there are still hundreds of thousands of measurements to be made.
It's a unique data set which allows you to understand how the seawater level raised during the last deglaciation.
Although the number of scientists who are involved offshore is limited, the number of scientists who can use the data is limitless.
ECORD has carried out one other MSP so far. Sandwiched in between Tahiti and Australia was a trip to the North American coast, the New Jersey shallow shelf. This time drilling back in time not 20,000 years, but 20 million.
And why did the scientists want to do that? They wanted to look at how climate had changed and how the sedimentary pattern had changed and how sea level had changed along that Atlantic coast.
This was different because it was not a ship. The first time we were working on a lift boat.
It was a stable platform, it didn't move, which made it more comfortable to live on. You didn't have the constant swell keeping you awake at night.
But on the other hand, it was the smallest ship or platform we ever worked on.
ECORD was a very small vessel, but the crew were fantastic, and I don't know, it was a really good atmosphere.
The result? Nearly 2,000 metres of core to add to the impressive archive in Bremen.
We've got a fantastic legacy for scientists coming on. Time and again, people go back to the core because new ideas evolve and they think, well, I could test that using this IODP core or that ODP core. So in a way, the possibilities are endless, or almost infinite, for the science that we can do with the core we recover and the data we generate.
A meeting at ECORD headquarters in Paris in February 2011. Around the table, a group of independent scientific assessors brought together to measure the achievements of ECORD over the past 7 years. Their findings will be read by governments across Europe.
I think it's fantastic that so many nations can work together on a voluntary basis and really participate both scientifically and technically.
I'm impressed by the way in which they have come up with a remarkable variety of new evidence, given that the difficult situations that they've been working.
One can be proud of the results up to now.
And ECORD is proud, but more than that, for everyone involved, it's a lot more than just a job.
You go to sea, you sail together, you spend 1 month, 2 months together on a ship with the same single aim. So it develops real ties.
One of the luckiest times in my life.
It's really pushed me and challenged me.
I feel very lucky doing this kind of work.
It's just opened my research up.
Ocean drilling is pure science.
If you look at all the scientific results that have come out of this, it gives us a huge sense of achievement.
I think it's important for everybody.
As the program continues, I think we are getting better and better.
We've learned a lot during these expeditions.
No one else on Earth has the expertise we have.
It's quite a big buzz to have brought it all together.
It's a great challenge.
Just the feeling that you were capable to do that.
It's also a big satisfaction.
Without this technology, without this capability of operations, then this science would not be able to be achieved.
It's unique material, it's brand new, it's fantastic.
You need to drill in the ocean, and we need a lot of more material.
We use satellites, we look at other planets and so on, but we still don't fully understand the planet that we live on.
I'm looking forward for the next expedition, wherever it is.